Basic premise of what we're doing at Tufts Cove from a scientific perspective is we are adding alkaline minerals to the ocean through a pipe. When you add these alkaline minerals, they're going to dissolve. And when they dissolve, they're going to neutralize acid. So you've sort of created a vacuum where more carbon dioxide from the air can be dissolved into the ocean to take up that void that you've created. So at the end, you have an ocean that is slightly less acidic than it was before. And you have some amount of carbon dioxide that's been taken from the atmosphere and stored in the ocean.
So this is PCA, it's the material we use. It's mostly magnesium oxide. So we get it from a plant in Spain, which is actually their waste. And so we're recycling it and using it for the purpose of OAE. We have great collaboration with Nova Scotia Power, and we use their outflow system. So we're actually using seawater from their cooling loop, putting our product in to create this slurry, and that's what gets sent into the water to actually do the carbon removal. Now we're inside the sea container where we have the bulk of our plumbing. All it really takes is 3 different pumps, 2 for each of the slurry trains and 1 for seawater. This is the intake line for slurry train 1, where it comes through this basket strainer here, which removes any clumps. Gets sent through this pump, where it just comes up here to meet the seawater line and the other slurry line, which gets sent out at the sea cannon into the inflow there.
We drop these sensors down into the water, and they're measuring an array of ocean parameters. So we've got everything from carbon parameters. So this sensor here is measuring pH, measuring ocean acidity. This sensor here is measuring the pressure of carbon dioxide in the water and in the air, because this sensor here is measuring air CO2. So you've actually got ocean and air CO2 measured simultaneously. As we add alkalinity to the water, we're going to see the CO2 content of the water go down relative to the air, and that's actually what's causing the CO2 flux from the air into the ocean. Of course, measuring the deacidification of the water is also very valuable. This sensor here is measuring temperature, salinity, ocean turbidity, so like how many particles are in the water, and chlorophyll, so the amount of sort of algal pigments in the water, so like measuring growth of photosynthetic organisms. And also pH, so we've got 2 measurements of ocean acidity side by side to make sure that they're sort of well calibrated. So it's coming in here through real time, and we can actually monitor these sensors remotely.
The environmental monitoring is very important because we want to make sure that whatever we're doing it responsibly and safely. We want to have a net positive impact on the ocean.
This concept of deacidifying the oceans, we're seeing it happen in real time. We've measured that vacuum in terms of creating a CO2 flux.
We faced a lot of challenges actually just trying to figure out how to handle and dose our alkaline material. We kind of had this revolutionary moment where we found the right recipe, we found the right residence time, and now that we've got this 2-train system, we're getting to the stage where we can dose at 2 tons an hour.
That little site, which I often describe as a tank on a tarp, can remove 10,000 plus tons of carbon every year. And you compare that to other kinds of solutions where you need large, complex facilities, huge amounts of energy to power complex machinery. You could take this operation and move it to a new location and start up very quickly. And so that ability to move quickly with a low energy footprint and a low sort of spatial footprint, that's the way you unlock sort of global scalability. And global scalability is how you unlock climate relevant impact.
When we're talking about the climate, 1,000 tons of carbon is nothing. We emit billions of tons every year. In theory, it should be simple to remove 1,000 tons over the course of a year. In practice, it's incredibly challenging, and it's incredibly challenging to do it for the first time. Achieving this has taught us a huge amount about our system, about how to optimize it, about how to come together as a team in order to make it work. It's given us the confidence that we can take this system and scale it to gigatons.